Hi all, and welcome back to Chapter 2. So in the last part of Chapter 2, what we're going to talk about is how to analyze our data. So after we've asked our question, we've formulated a hypothesis, and then we've tested it, we now have a bunch of data that we need to do something with so that we can understand the results. So this section is how we're going to examine that data. So the first thing you can do is use what we call descriptive statistics. So descriptive statistics is, like the name says, you're pretty much describing the data. You're also summarizing the data. And so these are the most common things that we're going to talk about here. And so for stats-wise, these are really the only stats I need you to kind of focus on for this class. In other classes, you'll learn about more advanced statistics, but today we're just going to talk about descriptive statistics. So the first type of descriptive statistics is what we call central tendencies. And so this is pretty much describing the middle point of your data. So all the data we call a distribution, so that's kind of the range. And then central tendencies would be what's near the middle. So some central tendencies, there's three different ones we're going to talk about. The first one is mode. So mode is just the most frequently observed measurement. So that really just means if you have a bunch of data, what number is represented the most, or which of the data is represented most. So even you could use mode for, say, if you ask a bunch of people their favorite color, whatever color has the most responses would be your mode. But usually for central tendencies, we're talking about numerical data. So data where you have a number system, whether that's a scale, that could be age, things like that. So the most commonly used central tendency would be the mean. So the mean is really just the fancy word for average. So what is the average measurement of all the data? And then the third one is median. So median is what is in the middle of the distribution if you line it up. So if you line up all your data from 1 to 100 or whatever your minimum to maximum value, whatever ends up being in the very middle, that would be your median. So here's an example of central tendencies. So if we look at on the x-axis someone's test score, so it's out of 1 to 7. And then on the y-axis here, we have the number of people that scored that. So here we have 2 people scored a 1, 3 people scored a 2, 5 people scored 3, and so on and so forth. For the mode, so remember mode is which score or which value is represented the most. So here, that would be 3. So 3 would be the mode because more people scored 3 than any other score. The next would be the mean. So the mean, what you're going to do is you're going to add up all the scores. So 1 plus 1 plus 2 plus 2 plus 2 plus 3 plus 3 plus 3 plus 3 plus 3. So you're going to add up all the scores and then divide by the number of participants. So here we have 15 total participants. So our mean, or the average, is a 3.27. So the average score is 3.27, so a little bit more than 3. So what that's saying is that half of the participants' scores was below 3.27 and half of the participants was above 3.27. So that's kind of how it goes. Again, this is an average, so it's not going to be an exact number most of the time. The third central tendency, again, is median. So that's when you line everything up and what's in the middle. So how you're going to do that is you can kind of cross them out. So we're going to cross out this person and number 7, cross out the other number 1 and the 6, cross out a 2 and a 5, and then the 2 2s and the 4 4, and then so now we only have 3s left. So what you do here is you continue to cross off top and bottom, there and there, and so this person right here is the median, the person right in the middle if you line everything up. Okay, so again, there's 10 scores below 3, 10 scores above 3. And so that's how you get the median. You line things up and then kind of cross things out, one from the bottom, one from the top, until you end up with what's in the middle. Now, when you're describing data, a lot of times your data is going to be presented in a graph form. So a graphical representation is quick and easy to be able to see all the data, because sometimes just looking at numbers can be a little overwhelming. So there's different types. So we've got frequency distributions, histograms, and box plots. So frequency distributions, this is kind of an example. So if you only have one set of data, you'd only have one arch, or what we call sometimes a bell curve. And this is just representing all the data for the people. So your minimum value or your smallest value will be on one side, your maximum will be on the other, and then the peak of it, that's going to be your average, your mean value is going to be right there in that peak. And so that's, again, that central tendency. It's in the middle of all the data. In this example, then we have 2 different frequency distributions where you can then see the differences between men and women. So again, this is a great way to not only visualize one set of data, but to compare between different sets of data. The second kind is called a histogram. So histograms are the most common you'll probably see because really they're just bar graphs. So bar graphs are the easiest, and it's like the graph we saw earlier, where on the x-axis you usually have a score of some type, and then on the y-axis you have the proportion or the number of people with that score or that number. So again, you can visualize what's happening. Now, the one downside with a histogram is you can't always identify the mean as easily. However, you can more easily identify the median or the mode. So like the mode here, the score would be a 0 here would be our score, because that happens the most often. Our median would probably be around here, again, because we can kind of cross these guys off, and it'd be more easy to figure out the median. So an advantage of frequency distributions is you're able to see the mean easier and compare between means, whereas histograms are better for looking at frequency of something, so that's more our mode and medians. The next one we're going to talk about are box plots. Sometimes you'll hear box and whisker plots. These aren't used too much in psychology, but I do want to bring them up. And this is really just a great way of looking at the spread of data. So it's kind of like a histogram, but on its side. But in this one, then you're able to really see the minimum and the maximum. And then we've got our median is the middle line of your box. And so remember that median is the number in the very middle. And then it's split, instead of just split in 2, we have it split in fourths. So our first quartile and our third quartile. And really what you do to get that first and third quartiles is after you get your median number, you'd then find the middle between the median and the maximum, and that'd be your third quartile. And then the middle between the minimum and your median is your first quartile. So this is a great way of seeing, again, the spread of data and where most of the data lies. So for instance, in this box, then you can see the distance between the first quartile and the median is a lot smaller than between the median and third quartile. So that means there's more participants scored within this small range than they did in this large range. So there's less of a spread here than there is here. So the median isn't going to be quite in the middle of the maximum to minimum on a number line. So it's going to be what we call skewed. So other than central tendencies, which are those three methods we just talked about, you can also look at variability. So variability is how much the measurements differ from one to another. So this tells us more about the spread of scores within the distribution rather than just what's happening in the middle. So in variability, we're going to talk about the range. So again, that's your smallest measurement and biggest measurement. You can represent that as one number by taking the largest measurement minus the smallest. And so you'll get a range. So say our range is from 1 to 5. To represent that range, we would take 5 minus 1, so our range would be 4. The second thing that we use a lot is standard deviation. So the standard deviation is the average difference between measurements. And this is a pretty complicated mathematical problem. Well, not too complicated, but too complicated for this class. So you're not going to have to calculate a standard deviation at all. Don't worry about that. But you do need to know what it means and what it represents. And the standard deviation is pretty good at describing the variability. So that's what we use the most. So this is just an example of, say, IQ scores. Remember, this would be our frequency distribution. The number in the middle would be our mean. The minimum would be over here on the left side. The maximum's over on the right side. So our range would be the maximum minus the minimum. And then we have these different colors. So what these colors are saying are the different standard deviations. So if you take the mean plus or minus the standard deviation, then that's what gives you what this dark blue color is. And then the mean plus or minus 2 times the standard deviation would be here, and then 3 standard deviations. And what these percentage means is that's always going to be the percent chance that someone's score will fall within this number. So the majority of scores of any distribution will fall within 1 standard deviation of the mean. So you can see that's about 68.2% of scores will fall within this dark blue section. Going out from that, the rest of the scores mostly will fall within these kind of medium blue to dark blue sections. That's going to make up even more. That's going to cover over 90%, over 95% of the scores will be within this range. About 2% will fall above 3 standard deviations, and then about 2% will fall below 3 standard deviations, so about 4% of the data will not be included in this main section. So just kind of know that most data will fall within 2 standard deviations of the mean. Okay. So we were talking about frequency distributions, and when talking about those, then a lot of times we'll talk about this thing called a normal distribution. So a normal distribution is pretty much just a perfect bell curve. the mean is directly in the middle and both sides are symmetrical. So you could fold it in half. Your mean's right in the middle, and exactly half the scores fall to the left and exactly half the scores fall to the right. So this is the ideal distribution that we always want. When I'm making a test, my goal is to make a normal distribution of test scores for the class, and that means it's not too hard and not too easy. It's a nice joke down here, paranormal distribution, it's a ghost. I'm really hoping it brought a smile to your face. So again, here's an example of normal distributions. So even though the men's distribution and the women's distribution are different, they are both normal distributions because they're symmetrical. If we folded them along this dotted line, they would fold perfectly over one another. So your normal distribution can have different peaks, it can have different ranges, but as long as it's that symmetrical thing, then it is still what we call a normal distribution. So I kind of addressed this a little bit, but other than a normal distribution, then we have what's called a skewed distribution. So if it's not perfectly symmetrical, then the only other option is that it's skewed. And what skewed means is that one side of the distribution is kind of pulled to the side. So for a positively skewed distribution, pretty much we have our distribution, but then we have this kind of tail that's going extra positive. And what that means is that the average should be right here in the middle at that peak, but instead you can see the mean has been pulled more positive. So in a normal distribution, the mean, median, and mode are all going to be the exact same number, whereas in a positively skewed number or skewed distribution, then the mode will still be that peak, but our median and mean will both be pulled to be more positive or higher than the mode, and you're going to get a tail pointing positive, pointing to the right. And that means more people, there were a couple people that maybe scored extra high compared to everyone else. So if everyone else is getting in the 70s, and then there was one or two people that got 100%, they're going to skew the distribution away from the average. Now the opposite of that would be negatively skewed. And so this one, then you have a long tail on that negative end or on the lower end of your scale. So again, the mean and median are pulled more negative than the mode. So we're going to stop that there, and then we have one more short video on ethics and what kind of conclusions we can draw from analyzing our data.